Okay, let's take a look here. We've got multiplying integers, okay? The rules for multiplying integers are if the signs are the same, okay, like a positive and a negative, either multiplying or dividing them, you're going to get a positive answer. So positive 5 times has to be positive 3 is our answer here. So positive 3 would give us positive 15. The signs have to be the same to make a positive answer. So this one's negative, that means this one has to be negative as well. So it is negative 14. Okay. This one, the answer is negative, so that means the signs had to be different. So that's negative 4. And this one, our answer is negative, so that means the signs had to be different. So we know 6 times 4 is 24. Signs have to be different, so it's positive 4. Okay. Number 2, list the pairs of integers that have a product of negative 20. So if we're multiplying things together to give us a negative answer, then that means that the integers have to have opposite signs. Okay, one has to be positive, one has to be negative. So first of all, let's figure out what we can multiply to get 20. Well, 1 times 20 gives us 20. So does 2 times 10. So does 4 times 5, right? And then the opposite of these, because the order doesn't matter in multiplication. So 20 times 1 gives us 20, 10 times 2 gives us 20, and 5 times 4 gives us 20. Now, they want to know which pairs of integers multiply to give us negative 20. Okay, so in order for that to happen, one of these signs has to be negative. Okay, I'm just going to make the first one negative in all these. So all of these equal negative 20. And these other 3 over here, same thing. If I make all of those, first one's negative. Okay, 1 times 20 is 20. One of them's negative, so it becomes negative. The signs are different. Okay, same thing here. 2 times 10 is 20. The signs are different. This one's negative. This one's positive, so it's negative 20, and so on. So there are the pairs of integers. Okay. Next one here, we've got some bed mass. So we're going to do what's inside the square set of brackets first. Okay, negative 6 minus negative 12. So we're going to use the temperature analogy because we're adding and subtracting integers here. Okay, this is subtraction. So if it's negative 6 outside, and Mother Nature takes away 12 degrees of coldness. Okay, it's negative 6, and she took away coldness. So if she takes away coldness, that means it warmed up 12 degrees from negative 6. So in other words, it's negative 6 outside, and the temperature went up 12 degrees. So that gives us 6. And then I'm going to write everything else where it was in the original statement here. The negative 2 multiply is here, and plus 10 is here. Okay. Now BEDMAS tells us we need to do multiplication before and division before addition and subtraction. So we're just going to go left to right here. So negative 2 times 6. The signs are different, so it's negative 12. And then I'm going to write plus 10 after it. Now if it's negative 12 outside and Mother Nature adds 10 degrees positive of heat, so it went from negative 12 and the temperature rose 10 degrees, went up, so it warmed up to our final answer here, which is negative 2. Okay, next one. Let's simplify these brackets. 5 minus 7 is negative 2. I'm going to write everything else where it was. So minus 3 times negative 4. Okay, so let's go left to right here. So we've got division, subtraction, and multiplication. So we're going to do division and multiplication first in order of left to right. So I'm not going to try and do a bunch of things at once here. I'm just going to simplify one thing at a time. So this is going to give me negative 7, because 14 divided by 2 is 7. But the signs are different. This one's negative, this one's positive, so our answer is negative. And then I'm going to write everything else where it was. Minus 3 times negative 4. Okay, now I have negative 7 minus 3 times negative 4. So I'm going to do 3 times negative 4. So 3 times negative 4 is negative 12. And then I'm going to write this other stuff in front of it, like so. And our final step here, -7 minus -12 is positive 5. So there's our answer, positive 5. Okay, again, we do the brackets first. 5 minus 7 is -2. I wrote everything else out where it was in the original statement. Working left to right, I got rid of division. 14 divided by -2 is -7. And then I just rewrote this stuff. And now I'm going to do this multiplication before this subtraction, because that's what BEDMAS tells us to do. So 3 times -4 is -12. Okay, 3 times 4 is 12. The signs are different. That one's positive. That one's negative, so it's -12. And this subtraction sign here, maybe I'll just highlight it here. This subtraction sign is the same as that. That's where that came from. And then our final step, -7 minus -12 is 5. Okay, and this number 4 here, the makers of Purr and Chew cat food want to price their cat food so that it costs just less than their main competitor, Happy Kitty. All right, so a 5 kilogram bag of Happy Kitty costs $12.99. All right, what is the maximum price that Purr and Chew should charge for their 4 kilogram bag of cat food? Keeping in mind they want to be cheaper than Happy Kitty. Well, first thing we're going to do is figure out how much does it cost for 1 kilogram of Happy Kitty. If we know we can buy 5 for $12.99, how much is 1? Well, it's simple division. The price divided by the quantity, 5 kilograms. Happy Kitty, and I had to round here, is $2.60 per kilogram. Okay. If Purr and Chew wants to be just cheaper than that, in other words, a cheaper price by, I'm going to say 1 penny, instead of charging $2.60, they're going to have to charge $2.59. Now, their bags come in 4 kilogram bags, so basically what I had to do was multiply $2.59 times 4, and that gave us $10.36 for 4 kilograms. So this is a cheaper per kilogram price at $2.59 versus Happy Kitty's $2.60. So in order for them to have just less of a cost than Happy Kitty, Purr and Chew needs to charge for their 4 kilogram bag of cat food a price of $10.36. Okay, here, use a proportion to solve each question. Use a variable for the unknown quantity. Okay, so what I've done is for this first one with lemons, we'll call this well, let's just figure out the answer, and then I'll sort of go back on what the variable could be. So basically when you set up a proportion, you always put price on top, okay? So if it's 96 cents, okay, for 3 lemons, how many is it for 8, okay? Once you have a proportion set up, basically it means that when I divide this number by this number, okay, 0.96 divided by 3, I have to get the same answer I would get if I were to take whatever this is and divide it by 8, okay? So how do we do that in math? Well, anytime you have a proportion, it means you've got 2 fractions, okay, that are said to be equal to each other, and you're given 3 of the values, so the top, the bottom, and the bottom here, and there's an unknown somewhere in the equation, okay? The easiest way to solve these, okay, is to always multiply the corners. So I'm going to multiply 0.96 times 8, and then, so that's the first step, and then the second step is to divide by the other number, wherever it is. So all you have to do on your calculator is 0.96 times 8 divided by 3, and that'll get you $2.56. Okay, so the cost of 8 lemons is $2.56. On B here, on a map, 1 centimeter is 125 kilometers. Okay, 1 centimeter is 125 kilometers. How many centimeters represent a distance of 550? So again, we've got a proportion here where we're given 3 of the numbers, top, bottom, bottom, and we're missing this top here. So all you have to do is multiply the corners, okay? You can't multiply these corners because you don't have this number. So this, 1 times 550, that's the first step, and then divide, like we did here, divide by 125, and you'll get 4.4 centimeters, okay? And that's how you do that one. Okay, number 6 here. Len's car uses 11 liters of gas per 100 kilometers of city driving and 8 liters of gas per 100 kilometers of highway driving. Okay, so what that means is in the city, if Len travels 100 kilometers driving around town, up to Sherwood Park, maybe he goes to work downtown and back every day from the south side, as soon as he's driven 100 kilometers in the city, he has used 11 liters of gas. Okay? And usually a car has about 40 or 50 liters of gas in the tank. So for about a quarter or a fifth of his tank of gas, he can travel 100 kilometers in the city. Okay? On the highway, your vehicle actually uses less gasoline per 100 kilometers. You would think, oh, if I'm traveling faster, on the highway, that my car is going to be using more gas. And yes, in some ways, but you have to remember that in the city, you're always starting, stopping, red light, slowing down, speeding up. Whereas on the highway, your car is traveling at a consistent speed. If you put cruise control on. So typically, almost always, vehicles actually use less gas on the highway than they do in the city, because you're just driving on a highway straight, from here to Calgary. You're not starting, you're not stopping, you're not slowing down, you're not, right? It's pretty consistent. So that's why those numbers, that's not an error, that is actually how cars and vehicles behave. So 11 liters of gas per 100 kilometers. Okay, so he traveled 600 kilometers in the city. So that means he used 6 times this amount. So 66 liters of gas. Okay, does that make sense? So 600 kilometers, that means he used, how many times does 100 go into 600? 6 times. That means he used 6 times this amount of gas, which is 66. Here he went 1500 on the kilometer, or 15 kilometers on the highway, and he gets 8 per 100 kilometers. So 15 times 8 is 120. So he used 66 liters of gas in the city and 120 liters of gas on the highway. So how much gasoline did he use that month? We just add those up. So 66 plus 120 gives us 186 liters, and that's how much gas Len used. Okie dokie.